Hello, good morning, everyone. So today's topic we are going to discuss is all about BGP messages. So there are four BGP message types. We have open, we have update, we have keep alive, and we have notification. Now, so if we talk about EIGRP and OSPF, we had hello packet to form the adjacency and to maintain the adjacency. But whereas in BGP, we have different messages to form the adjacency and maintain the adjacency as well. Here, open message is used to form the neighbor adjacency. Only forming. So, and maintenance is done by your keep alive. Any idea what is the keep alive timer in BGP? If you talk about the keep alive timer and the hold on time, is by default 60 and hold on timer is 180 seconds. So every 60 seconds, a keep alive is sent in order to say he is alive. And hold on is 180 seconds. And update message, it is used to exchange the routing information. So notification message is sent. If any error occurs in BGP, then a notification is sent. These are the four message types. Done? Now, so we'll talk about BGP adjacency states. Important BGP neighborship states, anything else. So we have 6 BGP neighborship states. So how many OSPF has? 8. We have 8. Down, attempt, init, two-way, extract,
exchange, loading, fold.
Good. So in BGP, we have 6 neighbor states. We have idle, we have connect, we have active, we have open sent, we have open confirm, and we have established. So initially, both the routers are in the idle state. Until unless you enable a neighbor command, or you enable BGP process. Please mute. So in connect state, routers will try to establish TCP three-way handshake. If successful, it will move on to open sent. And if unsuccessful, then they will move on to active state. Okay. Now, so in active state, again it will try to re-establish. TCP three-way handshake. Successful, it will move to open sent. If unsuccessful, it remains in the same state. Yes, depends in the same state. Again, after 60 seconds, a reconnect timer will start. Please make a note. Let us consider if it is unsuccessful. A reconnect timer is there. So by default, it is 60 seconds. If it is unsuccessful, again it will try to re-establish the TCP 300 until and unless it is successful. If it is not successful, every 60 seconds it will try to re-establish. Clear? Successful, it will move on to open sense. Shall I rub this? This is done. Noted idle. Now opens. So in open send state, it will check the BGP ASN number, BGP version, router ID, neighbor command. So if everything is properly configured, then it will move on to open confirm. If any error, then it will move on to idle state. Sir, this is the idle. Because TCP, only TCP problems will go to active. Otherwise, again, you can say depending on the error. This is done. Active is done. Next state is open confirm. So in open confirm state, BGP neighboring router, if it sends an open message, it will move on to established state. Or if the BGP neighbor sends an notification message, depending on the error, it will move on to either active state or idle state. If it sends means this is the neighboring router. If the neighboring router sends a notification message, then depending on the error, it will move on to either active or idle state. Same statement. There is no space. Please mention the same. It will move on to it will move on to either idle or active state. Should I write it here? Idle or active. No? Is it done? Established full adjacency. So two BGP routers. Yeah. Full adjacency or neighborship. Yep. Done. Okay. Now we'll see how to form iBGP and ebGP adjacency. So BGP has two flavors. It is iBGP. What is the AD value of iBGP? 200. And ebGP is 20. So what do you mean by iBGP? Same ASIN. Same autonomous system number. So what about ebGP? Adjacency between two different ASIN. So now we'll see how to form iBGP and ebGP neighborship. Let us consider we have two routers. Let's start with the two, then we'll increase the routers. Yes, 12. Yes, 2. This type of neighborship adjacency we call it as ebGP. Now, how used to enable? Let us consider we have the network 12.0/24.1.2. This is also 192.168. Sorry. .0/20. So now how to enable BGP adjacency? How used to enable in EIGRP and OSPF? Let us consider I want to advertise this thing. What was the command? Under router, EIGRP, ASN, and network and the directly connected networks. But here, network command is used to only advertise the networks. So in order to form the adjacency or form the neighborship, you need to use neighbor command statically. Clear? Now let us consider I want to form adjacency on R1. So first command, please make a note, router BGP ASN, that is 12. So BGP router ID. This must be unique. 1.1.1.1. Then neighbor command. Neighbor, you need to mention the neighbor IP, that is 192.168.12.2, and you need to mention the remote AS of the neighbor. What is the remote AS of the neighbor? It is again 12. So since the R1's atomic system number and the remote AS atomic system number is same, so that's why we call it as iBGP. Now let us consider we have a loop back here. Adjacency is done. Now in order to advertise these loopback or these networks, we use network command. This is used to form adjacency and this command is used to advertise the networks. And you need to must specify the mask, that is /32. This is how you advertise.
So do we need to advertise this 12.0 also directly connected network?
No, not required.
Okay.
So in the same way, on R2, so router BGP 12. This must be unique. And the current BGP version we are using is version 4. Please make a note. BGP router ID 2.2.2.2. So neighbor IP. So even you can form the adjacency with the help of loopbacks. We'll see that later. 12.1. And what is the remote AS? Remote AS is 12. Routing information is sent by update. In open message, it will contain all these informations. Your ASN, your neighbor, remote AS, your router ID, everything will be checked in the open. So then let us consider we have look back here. So we'll use network command. 2.2 mask /32. Clear? This is how we form iBGP adjacency. I hope this part is clear. Neighbor command is used to form the adjacency and network command is to advertise the network. So now we'll see a lab. on both iBGP and ebgp. Yes, you can do that. Yellow packets. What is the name? Yes, you can do that. We'll see. Remote adjacency also you can form, but you need to have a reachability. So we can use any IGP protocol. Then you can form remote adjacency as well. Yellow packets. Clear? Okay. Now we'll see how to form iBGP and ebgp. Even you can form the adjacency with the help of loopbacks as well. We'll see. So let's take two routers. So both are in the A center. IP address between R1 and R2 will be 192.168.12.0/20. We have loopbacks on R1/32. We have a loopback on R2. That is 2.2.2.2/30. For the console. So on R1, basic IP address. IP address will be 192.168.12.1/. We have interface loopback. IP address will be /30. No, that first time. Then next time we'll do it in the loopback. So good with BGP, you can enable BGP here. 12.2/24 and loopback 0 2.2.2.2. Just copy paste on R1 and R2. So on R1. So now how to enable BGP? Router, BGP, you have to mention the autonomous system number, that is 12. And BGP router. This must be unique in order to form the BGP adjacency. Yeah? Then the neighbor command. Who is your neighbor? 192.168.12.2 is my neighbor. And what is the remote address of the neighbor? That is 12. Done? So go to R2. Once we adjust the adjacency, then we'll like, just to show with the neighbor only, it will not advertise. Because otherwise, so many people will get confused. So neighbor, router, BGP 12. BGP router ID 2.2.2.2 and neighbor. Who is my neighbor? 12.1 and the remote address will be again iBGP adjacency. Form a neighborship for the neighborship. I see the BGP adjacency is up. Now how to check the BGP adjacency? Show IP BGP summary. This will show you the neighborship. And here the state must be always 0. You should not see here as active or either idle. Then you have a problem with BGP adjacency. You should always see here it as 0. This is the version 4. Current version we are using the BGP. It will tell you the remote ASN number. This is the neighbor IP. These are the message sent and message received. This is table version, input queue. Don't worry about this. When we have an error, then we'll be having this input and output. So this is the uptime, how long your neighbor adjacency is up. And these are the prefix received. Can you see here 0? Now I have not advertised anything inside the BGP. Now how to check the BGP table? Very simple, just remove the summary. This is how you check. There is nothing because I have not advertised anything on R1 or either on R2 as well. Now we'll go to R1 and advertise. So router BGP 12. Advertise the loopback, that is 1.1.1.1, and must you need to specify the mask and exact mask. Right. Enter. Yeah. Go to R2. Router BGP 12. Network 2.2.2.2. Mask short form of mask is here. Yeah. Now if you go and check on R1, show IP BGP. So this is self-originated. How we will know? Depending on the next hop. Next hop, if it is 0.0.0.0 means locally injected, or we can call it as self-originated routes. So this route, what is it? It is from the neighboring router, that is next hop. 12.2. Don't worry about this. This we'll discuss. Wait, these are the attributes. We have wait, local preference, AS path, MED. These are the attributes. I hope this part is clear.
The show IP BGP same as show IP route BGP.
Show IP route. Yes, you can see. You can see two route BGP 200. This is iBGP. Clear? Now we'll see how to form ebgp adjacency. Same lab. Yes, one. Only the best route. I'll top of it. Don't worry. ASM. This is an ASM. Go to R1. So no router. BGP. to R2. Domain lookup. Just wait. Okay. No router. Now go to R1 and enable BGP. Router BGP 1. BGP router ID 1.1.1.1. So neighbor 192.168.12.2. What is the remote AS? Remote AS will be 2. And advertise the loopback slash 30. This is how you form ebgp SSH. Go to R2. BGP2. BGP router ID will be 2.2. Neighbor 192.168.12.1. Remote AS LP1 and advertise the loopback. Mask slash to check the neighborship, show IP, BGP, something. Form, and here it is showing it as 1. It has received a loopback from R2. Can you see? And show IP route BGP. This time, AD value will be 20 because this is ebgp. Clear? This is how you form iBGP and ebgp adjacency. So now, this is clear how to enable BGP and how to advertise the loopbacks. So now we'll talk about iBGP loop prevention mechanism. Anybody has any idea how iBGP prevent the loops? Yes. MK loop prevention mechanism. Yes, online guys, any idea how a loop is prevented inside iBGP?
It won't advertise to the, like, whatever is received from a peer, it won't advertise to further.
Okay. What is the mechanism called? Good. What you told is 100% right. What was the mechanism called?
Split horizon or
Very good. It is called iBGP split horizon. What do you mean by that? So let us consider we have 3 routers. We have R1, R2, and we have R3. So all are in the same autonomous system number, ASN 1, 2, 3. So now let us consider we have a loopback slash 32. This is 192.168.12.0 slash 24. This is 192.168.23.0 slash 20.2. Now, so now let us consider we have formed the adjacency is fine. So I have formed adjacency between R1 and R2, and R2 has formed the adjacency with R1, and R2 has formed the adjacency with R3. Now, so after the adjacency, so whenever R1 advertises to R2, that is any iBGP neighbor, due to iBGP split horizon. Please make a note. iBGP split horizon rule. R2 will never advertise this loopback information to another iBGP neighbor. This is iBGP split horizon.
This happen only in case of loopback addresses, sir.
I didn't get it. Means,
This happen in case of only loopback addresses only.
so what do you mean? Means loopback addresses means whenever we
Uh,
advertise anything.
Let's say with R1 we have one subnet 192.168.20.0. So it will come to R23 through
No, R2 will not
iBGP.
advertise. Save everything. Same. So whether it is a network. Yes. Yes. Done. So first we'll prove the iBGP split horizon, then we'll see how to break this split horizon. Done, right? Let's create the same lab. Let's take one more router. So between R2 and R3 it will be 23.0. And ASN 1. Clear? So we'll advertise the loopback on R. So let's prepare a notepad. So everything is fine. Okay. Configure. IP address will be 192.168.12.1/20 interface loopback. Slash. Correct. So router BGP 123 BGP router ID dot 1 dot 1.1 and neighbor 192.168.12.2. Remote is will be 123 and advertise the network. Mask slash then on R1. So okay on R2. So Z0 bar 0 will be 192.168.12.2 interface Z0 bar 1. IP address will be 192.168.23.2/20. Don't have a loop back here. Not required. Router BGP 123. So BGP router ID will be 2.2.2.2. So neighbor 192.168.12.1. Remote ACE will be 123, and we have one more neighbor command, that is 192.168.23.3. Remote ACE will be 123. Done. Don't have a network. Now go to R3 and enable. So Z0 bar 0, 192.168.23.3. We don't have Z0 bar 1. Router BGP 123. So BGP router ID will be 3.3.3.3. And we have one neighbor, that is 192.168.23.2, and remote ACE will be 123. I hope the configuration is clear. Any doubts with the configuration? Clear, right? Okay, just copy paste on R1, R2, and R3. Yes? No, we are not mentioned. If you want, you can. But for this concept, we don't require. You can take a look back, you can advertise. R2 and R3. Go to R1. So R1 will have one full adjacency. Question. What to check? Show IP, BGP, summary. I have one adjacency with 12.2. What is the remote is? Remote is 120. And BGP is fine. You to check this the last two. It should not be idle or either active. So go to R2. R2 needs to have two neighborship. Show IP BGP summary. I have one neighborship with R1, that is 192.168.12.1, and everything is fine. And even we have neighborship with 23.3. This is also working fine. Now go to R3. Show IP BGP. This is also fine. We have neighborship with 23.2. Clear? Now. So go to R1. Check the BGP table. Show IP BGP. Self-originated. Now go to R2. Show IP BGP. Able to see the route? Now go and check on R3. R3 will never have this. Why? Because of iBGP split horizon. So now how to break this split horizon? Any idea how to break this split horizon? Full mesh. Full mesh. How? And just form adjacency between R1 and R3. Full mesh. Every router should have adjacency with every other router. Clear? I hope low packets is clear. This is how you form a remote adjacency. With BGP, it is possible to form remote adjacencies. Clear? Now go to R1. So router BGP 123. So neighbor, what is the neighbor? 192.168.23.3. What is the remote AS? Remote AS will be 123. Enter. Go to R3. They will not form the adjacency. Why? So router. Yeah. After mentioning also will not form that. Yes. See neighbor. What is the neighbor? 192.168.12.1. Correct. Remote AS will be 120. No adjacency. Why? Check show IP BGP subnet. What is the state? Never means idle. Now you will see idle state. Why? Can you see here? I don't have adjacency here. Why? Can you see the idle state here? I don't have any adjacency between R1 and R3. Why? Very good. Reachability. That's what I talked about. Reachability. Just as soon as you see idle state, just initiate a ping. I don't know how to reach 12.0 network. So either you can use a static route or you can use any IGP protocol for reachability inside iBGP. Clear? So let me configure static IP route. Yes, tell me.
Sir, that means split horizon is a drawback kind of thing. Meaning, even though it's in
Good
the,
one, Anika. Yes, tell me.
even though if it's in the same ASN, R3 cannot ping 1.1.1.1.
Correct.
Now.
We don't have reachability.
Right. Meaning it's split horizon is it kind of a drawback, sir, rather than.
It's not a drawback. That's how iBGP works.
Okay.
That how iBGP avoids the loops. Clear? 192.168.12.0 and specify the subnet mask. Specify the next hop. Next hop will be 192.168.23.2. Enter. So now go to R1. IP route 192.168.23.0/24 and next hop 12.2. Now they will form the adjacency. You see adjacencies are reachability. Show IP BGP. I hope now it is clear. We have two beautiful adjacencies. So on R3 also show IP BGP. Some I have two adjacencies. So now check the BGP table. Now you can find the route. Can you see? And you can. I hope this part is clear. How to break iBGP split horizon. I hope this is clear. So not only static route, you can use any IGP protocol for reachability. You can use either ebgp or OSP. Clear? Okay, so we'll take a short break. We'll come back. So we'll discuss about ebgp loop avoidance mechanism. So we'll come back by 9, 12, 9:50. Let's start. Let's see ebgp loop prevention. Any idea how eBGP will implement the loops? Why? No, no. Okay, let us consider we have 4 routers. Done. So R1 is in ASN1. R2 is in ASN2. R3 is in autonomous system number 3, and R4 is in autonomous system number 4. So let us consider 12.0/24. So the network will be 192.168.x.x/24. This is dot 1, this is dot 2, this is 23.0/24, dot 2 and dot 3. This is 34.0, dot 3, dot 4. This is 14.0/24, dot 1 and dot 4. Now, from the R2's perspective, let us consider we have a loop back. Correct? Now, when you check the BGP table, 1.1.1.1. So R2 can receive from R1 directly, or R2 can receive from R4, from R3, and from R2 as well. So now how it avoids the loop is based on the AS path information. So there are 2 next stops. It is either 192.168.12.1, and we have one more next stop, that is 192.168.23.3. So for 12.1, what is the AS path? AS path is 1. From R1 to R4, R4 to R3, R3 to R2, what is the ASN number? It is 1, 4, and 3. Now, which path it will select? It will select the least AS path. So how it avoids the loops? Based on the least AS path.
So does it mean number of AS path or numbering it order low?
Least.
Okay.
Yeah. So we'll see this, how it works. This is done. CL app. So let us consider 4 routers. So we have R1, R2, R3, and R4. So R1 is an autonomous system number 1. So R2 in autonomous system number 2. R3 is in autonomous system number 3. And R4 is in autonomous system number 4. So the IP address between R1 and R2 will be 92168.0/20. So IP address between R2 and R3 will be 192.168.23.0. Between R3 and R4, 34.0. And between R1 and R4, it will be 14.0. And we have a loop back on R1. Notepad. So on R1, so interface Z0 bar 0 will be 12.1. And one more interface, that is Z0 bar 1. So IP address will be 192.168.14.1/20. We have a loop back. So router BGP 1. So router ID will be 1.1.1.1. So we have neighbor with 192.168.12.2. What is the remote AS? Remote AS will be 2. We have one more neighbor, that is 192.168.14.4. What is the remote AS? Remote AS will be 4. This is the configuration on R1, and I have advertised the loop back as well. So on R2, so Z0 bar 0 will be 192.168.12.2, and Z0 bar 1 will be 192.168.23.2. Remains the same. So router BGP 2. BGP router ID will be 2.2.2.2, and we have neighbor command with 192.168.12.1. What is the remote AS? Remote AS will be 1. And neighbor with 192.168.23.3, and remote AS will be 3. Done. So now on R3. So on R3, so interface Z0 bar 0 will be 23.3. We have one more interface, that is Z0 bar 1. So IP address will be 192.168.34.3/24. So router BGP 3. BGP router ID will be 3.3.3.3. And neighbor 192.168.23.2. Remote AS will be 2. And we have one more neighbor, that is 192.168.34.4. Remote AS will be. Enter. Now final configuration of R4. So interface Z0 bar 0. 192.168.14.4. So Z0 bar 0 1 will be 34.4. So router BGP 4. So BGP router ID will be 4.4.4.4. We have neighbor command with 34.3. Remote AS will be 3. And we have one more neighbor command, that is 14.1. Remote AS will be 1. I hope the configuration is clear. Okay, let's copy paste. R2, R3, and R4. So R2 can get the loopback from R1 with AS path 1, and R2 can get from R3 as well. What is the information? I got it from 1, 4, and 3. So it will always choose the least AS. Okay. So now, so now R2. R3. Then R4. So check the BGP adjacency. So R1 should have 2 adjacency, one with 12.2 and one with show IP BGP. R2 adjacencies, one with 12.2, one with 14. So go to R2. R2 should have adjacency with R1 and with R3. So 12.1 and with 23. Clear? Go to R3 and check the neighborship. So IP BGP adjacency with R2 and R4. Please mute. Now R4. Again, 2 adjacencies. One with R1, one with R3. It's 14.1 and 35. Now go to R2 and check show IP BGP. So it is accepting from 1. So go to R4, check the same. So show you 2 paths. You can check it here. Even R2 should show 2 paths. So one more key point to remember: star means what? These both are valid. Means I can reach via 34.3 or I can reach via 14. Just valid routes. Only the best route with greater than symbol will be installed in the routing table. Can you see the best? Please make a note. Star means valid routes. So both are valid, but I am choosing 192.168.14.1 as the next of. Why? Because of least AS path. Can you see? Optimal. Best. If I go with 34.3 neighbor, I need to cross 3 ASNs. So this is how it avoids the loops. Least AS path. ebgp loop approach. R3 will load balance. Not load balance. It's oldest ebgp. There are so many. So R3 will always choose first come first. So let's consider, go to R3 and check. So we want to check here, show iBGP. Let's chosen 23.2. Why? Only one. No, both are same. Can you see 2 to ASN? Don't have a problem. AS path is same. Now, why it has chosen 23.2. Why not 34.4? Because the AS path is same. BGP by default doesn't do load balancing. No. Before that, before least neighbor router ID, we have one more attribute called as oldest ebgp route. So if you check the attributes, we have next hop, we have wait, we have local preference. So we have locally injected. AS path is the same, least AS path. Then after that, we have origin. Origin means I use the network command on both the sides. That will not matter. Next, MED, I have not set any MED. Neighbor type is the same. It is ebgp for both. IGP, I have not used IGP. Least IGP known metric, I have not used any IGP. Oldest ebgp route. Here it is there, ebgp route. Then it will check least neighbor router ID, or router ID is not configured, then least neighbor interface ID. So next hop, both the hops are reachable for R3. Not at all a problem. I have not set any weight. Weight is by default weight, that is 0. Local preference is by default local preference, that is 100. So locally injected, it is not locally injected. AS path is the same. Origin, it is originated from network command. MED, I have not set any MED. If you talk about neighbor type, both are ebgp. This is also ebgp, this is also ebgp. IGP known metric, sorry, it is not IPG, it is IGP. So I have not used any IGP here. Now it will come to oldest ebgp route. Means from whom I have established the adjacency first, I will choose that path. So now R3 has established the adjacency first with 23.2, that is R2, then with R4. So oldest ebgp. How to prove this? Just go to, so R3 has chosen R2, right? Just go to R2 and shut it down. In order to just prove this. Extra thing. Router BGP. This 2. So neighbor 192.168.23.3, right? Shut down. Now, shut down then. Now it will choose. So go to R3 and check. Show IP BGP. Now it will choose 34.4. Now bring that interface up. It will never revert back to R2 because oldest. Now I am choosing 34.4 as the next stop. Now go to R2 and remove that shutdown command. Sorry, R2. Just go here. So no, remove this. Done. Membership is up. Now go and check R3. R3 will never choose 23.2 because of, can you see, it has stuck on to 34. Why? Because of oldest ebgp, hence proved. Clear? No doubts, right? Here now. Okay. So to check the attributes. So now moving on. So now we'll see how to form the adjacency with the help of loopbacks. Let us consider we have R1 and we have R2. A center. So we have 1.1.1.1/32. 2.2.2.2/32. So with BGP, you can form adjacency with the help of loopbacks as well. /1.1. Okay, this time we'll form the adjacency with the help of loopbacks. We'll see iBGP and ebgp, and then we'll end. Yes. Done? Okay. So let's proceed to the lab. We'll see how to form the adjacency with the help of loopbacks. So let's take two routers. So 192.168.0/20 slash 32. We will look back on R2 as well. That is 2.2. Both are in the same autonomous system now. Hmm? So R1. So we will require this. So 0/0 is 12.1, right? And we have a loop. Now to 0/0 will be 12.2. We don't require this. Just remove this, and we have a loop back. Just copy paste. Wait. Copy paste. Basic IP configurations. Done. So now go to R1. Now how to form the adjacency with the help of first command router BGP. BGP router ID. Dot on dot. So now neighbor. Now what is the neighbor IP? I want to form the adjacency with the help of loopback. So my neighbor IP will be the loopback IP of R2. What is the remote AS? Remote AS is 12. Enter. And advertise the network. I don't want to advertise because I'm forming the adjacency with the help of loopback. No need to address, right? Because I'm forming with the help of loopback only. Just go to R2. Router BGP router ID will be 2.2. Neighbor. Who is my neighbor? What is the remote AS? There is no adjacency. But Can you see? Show IP BGP sum idle. Again, the problem is with what? Reachability. I don't know. Flipping 1.1.1.1. I don't know how to reach to 1.1. Yeah. Create a static route or use any routing protocol. Okay. So let's create a 1.1.1.1 slash 32. What is the next stop? 92168.12.1. Done. So go to R1. Create a static route. The next stop. 12. Now also we don't have adjacency. Can I see idle? Can I ping? Yes. Reachability I have. I know how to reach to. So I know how to reach, but still no adjacency. Why? Now the problem is here. So now what BGP is thinking is, so what I have configured here? Went and configured neighbor 2.2.2.2 remote is as 12. We went here and configured neighbor 1.1.1.1. What is the remote is? Remote is as 12. So what BGP is thinking is BGP is forming adjacency with the exit interface. So you need to have one more command in order to update your source. You need to tell, right? You know, tell neighbor 2.2.2.2.2 who is my source. My source is not the exit interface. My source is loopback 0. So you need to update the source because you are not forming adjacency with the help of exit interface. This is the problem why it is not forming the adjacency. So you need to go to again R2 and configure neighbor 1.1.1.1 and you need to tell him you need to use my loopback to configure, to establish the adjacency. Yeah. You need to update your source by using this command. Done. So now go to R1 and update your source. This is done. Comments is done. Go to R1 and go to R2. Just update the source. Go under BGP. BGP 12. Neighbor, who is my neighbor? 2.2.2.2 and update this source. Loopback 0. Go to BGP 12 and update this source. Can you see adjacency is up? Update source. Loopback 0. Show IP BGP summary. Can you see we have a beautiful adjacency. Why? I hope now this part is clear. Show IP BGP summary. Clear? Now, if you want to advertise any network, so let us create another loopback. So interface loopback one. So IP address, let us consider 22.22.22.22/32. Go under BGP and advertise this. Router BGP 12 and network. Mask slash show IP. Next stop is 00 self-originated. Go to R. Who will be my next stop? My next stop is not exit interface. Next stop is the loopback. So I am forming the adjacency with the help of loopback. Even the updates will be sent to the loopback. I hope this part is clear. So anybody has any doubts till here? Okay, guys. So today we'll end up. We'll see eBGP with loopback 0 tomorrow. Yes, online guys. Any doubts? Anybody has any doubts?
Sir, I have one doubt on
Yeah,
that.
tell me.
ASN. So, for example, previously in ebgp, like we took the example of 4 ASNs.
Yes.
So, for R3 or R2 going, or let's say R3 going back to R1, right? To
This was a topology, right? Balaji?
yeah, yes, sir.
1 minute. So let me draw this. Yeah, tell me, Balaji.
So, the least AS path, right?
Mhm.
Meaning, so say, okay, let's say R2 only going back to R1, right? So it's just one ASN away.
Yes,
Right.
correct.
So and the ASN number we give, right? So
Mhm.
does that number has any weight? Meaning, like R1 can be in ASN 100 also, right?
Yeah, anything it can be. That is not
That's just a
mandatory that
number.
it is ASN1. It can be
Okay.
anything. It's up to you.
So that number doesn't have any preference.
No.
Okay.
It can be in any ASN number. That is not at all a problem.
Okay. So least ASN path is like
Yes,
ASN hops it is going.
Yes.
Okay.
Correct. You are right, Balaji.
Okay. Thank you, sir.
Yes, guys. Anybody has any other doubts? No doubts? Okay, guys. So today we'll end up. We'll continue tomorrow. Have a great day. Bye, guys.
Okay, sir. Thanks.
Okay.